Let's use example 911 on page 332 to demonstrate how to solve simultaneous equations with complex numbers using a TI calculator. First, we need to apply the node voltage method to determine the equations. We will write a KCL equation at node 1 and at node 2. Since we have a dependent source, we also need to write a constraining equation that describes the dependent variable Ix in terms of the unknown node voltages, V1 or V2. The circuit analysis yields three equations with complex coefficients in terms of three unknown variables, V1, V2, and Ix. To organize your work, rewrite the equations in a matrix format where you will represent each equation as one row. Put all of the constants on the right-hand side of the equation. Now you can formulate your problem as a simple matrix equation. Matrix A times the unknown vector, we'll call it X, is equal to the constants vector, we'll call this B. You can use your TI calculator to solve matrix equations with complex coefficients. The TI-83 and TI-84 calculators do not have the capability to make matrix calculations with complex coefficients. However, you can download a freeware program written for the TI-83 that will solve simultaneous equations with complex coefficients. Follow the instructions to download the LinSYS program. Once you have downloaded and installed the LinSYS program on your calculator, you can solve this system of equations. First, access the LinSYS program from the Program button. Hit Execute, hit Enter again. Now the program is asking you to enter the number of variables in your system of equations. We will enter 3. Next, the program is prompting you to enter the coefficients that represent your first equation. For example, A1 is the first coefficient of the first equation. Enter 1 divided by 10 plus 1 divided by the quantity 1 plus J2. You can enter the coefficients in either rectangular or polar form, and you should do this exactly the same way that you enter complex numbers in your calculator. Next, you will enter in the rest of the coefficients for the first equation. When you are prompted to enter the value for B, this is indicating the constant associated with the first equation. Now that you've completely entered equation 1, you will do the same for equations 2 and 3. Once you have finished entering the data, you should select what format your complex numbers will be displayed. Choose either polar or rectangular format. The program will return the answer in the order that you entered the equations. You need to page to the right to see the entire answer. For example, we can conclude that V1 is equal to 68.4 minus J 16.8, and so on.